Hey guys, it's Mr. Sheeline. This is going to be the video for the Check Your Understanding number 2 for the conservation of momentum in 2 dimensions notes. So in this example, we have a 10 kilogram ball traveling forward at a rate of 3 meters per second, and then it strikes a 5 kilogram ball sitting at rest. The 10 kilogram ball then continues to move 2 meters per second, 30 degrees above the horizon. And we are tasked with finding the final velocity and also angle of the 5 kilogram ball after the collision. Okay. So let's do what we normally do. Let's write down what we have, what we don't have. So we're going to say we've got, so the first ball here, we've got a mass of 10 kilograms. And it's traveling at a rate here of 3 meters per second forward. Good. And then we've got the mass here of a second ball, which is 5 kilograms, the velocity of 0. Now, if this were a one-dimensional problem, we wouldn't have to do this, but like we mentioned earlier in the notes, we care about x and y values now. So reading into this, I mean, if this is forward, it's going to the right. This is not just, an initial velocity, it is initial velocity in the x direction, and so would this be. So we would have, and just to be aware, we're going to be it's going to get quite confusing with all these subscripts, so it's best to keep these as similar and same as possible, and I'm going to try my best to keep them the same as much as I can. So just bear with me if I accidentally go off or if I mislabel something. Okay, so these are initial, as well. So here we start off with this. The first thing that we should do after, establishing what we have and what we don't have. We don't have the final velocity of our second object here. Nope, see, I've already done it. We don't have of our second object. We do not have the final velocity. Also, we don't have its angle, but we do have theta for our first object, which is 30 degrees. And we also have the final velocity for our first object. We have that too, and that's 2 meters per second, okay, at that 30 degrees. And I'll even add that 30 degrees above horizon. Okay. So let's do what we normally do in this kind of situation. Let's draw it out. Let's see what's happening here. So we've got this 10 kilogram ball that's moving forward here at a rate of 3 meters per second. I'm going to offset this ball just a little bit, this 5 kilogram ball. Offset it. It's going to bump into it like it would with billiards. This guy is going to go upwards in this direction, while this guy is going to go downward in this direction. This guy moves at 2 meters per second here and is at 30 degrees from the horizontal. We're going to find out what this angle is, and we're also going to find out what this final velocity is right here. So this is what we're doing, and I know this seems kind of spooky that it doesn't seem like we have a whole lot to work with here, but actually we have just enough, and we have plenty of things to work with in order to find out what the final velocity is ultimately, and also the angle in which it is projected at. Also, if you didn't know, this is phi, so I'll be using theta. So this is theta. This right here is phi. So when you see that, we use this just to differentiate between 2 angles. So theta will just be, in this case, it's the one given. Phi will be the one that's not given. And this is usually how I set it up. I'll have theta above, phi below. Okay. So now, let's just do this. Instead of trying to figure out exactly what to do with all of this, let's just split this in half. Let's just focus on this guy right now, since he has most of the variables. He has most of the values that we need to work with. And let's break down his set of motion the final set of motion into a triangle. Let's just do that. So here's his horizontal motion, here's ultimately his final motion, and then here's his vertical. Okay, so he's got an angle here of 30 degrees. He has a final velocity. He's got a final velocity here of 2 meters per second. Okay, now we need to find out what these two components are. Now, what are those two components going to be? Well, just like we talked about with the first problem, we can't simply just use, we can't use SOHCAHTOA here using the velocity, because we have to take into account the mass of this object. So, in this case, we're going to first figure out what the final momentum is at this angle for this object here. Okay. Why do we want that? Well, we need, specifically, we're going to need the final momentum horizontally and also the final momentum vertically in order to find out what the final vertical and horizontal momentum is for our second object. Because as we know, initial momentum is equal to final momentum. So let's figure out what this is. So we're going to look for the momentum, and we'll say the momentum of object 1, and it's its final. We need to figure out what that is. We're then going to need to figure out what the final y momentum is, and then what the final momentum is in the x direction for object number 1, this 10 kilogram ball. Okay, so to find this one, relatively simple. It's going to be the angular velocity that we already have, the final velocity it's moving in, 2 meters per second times its mass, which is just 10. So that's going to be 2 times 10, which is going to give us a 20 kilograms by meters per second. Okay, so we've got that. Now, before I get into, because I'm sure you're seeing it already, how we find these two, but let's just write this down so it makes sense in our brains here. So remember, initial velocity, so initial, and I'll break this down to x, y components. Initial velocity in the initial momentum in the x direction is going to be equal to the final momentum in the x direction for both of these situations. Here, we can actually, we're going to use this guide in order to figure out what the, to make sure we've got this all right. This right here, okay, so this right here is going to be the initial velocity, the initial momentum before the collision. So all that is, it's going to be m1 v1 initial in the x direction plus m2 m2 v2 I in the x direction. Okay, which, and I'll put this over here, which this is easy. That's 0, okay, because our initial velocity is 0 for our second mass. It's at rest, so we ignore that. So then it's just 10 times 3 meters per second. It's going to be equal to our initial momentum in the x direction, which is going to make our initial x direction the horizontal momentum, your initial horizontal momentum is 30 kilograms by meters per second. Okay, and we'll say this direction. Though that is a little redundant, since I guess it's not terribly redundant actually, but we understand it's going to be in this direction. So now I didn't find this right here using this. Okay, this is separate. I'm just saying that this is, we're going to be using this in order to figure out what the momentum is for, the final momentum is for our second object, because that's what we need to figure out. So with this understanding, okay, knowing that our initial x momentum is equal to our final x momentum, we can use this to find out all the stuff for this guy. But first we need to find out this, okay, because we should know that, just like over here, the final x momentum is going to be equal to the final momentum of our first object plus the final momentum of our second object on the x-axis. Okay? Okay. And we already know this has to equal this, so what this really can translate into is just this. The initial x momentum is equal to the final momentum in the x direction for our first object and the final momentum in the x direction for our second object. Okay? So let's now try to figure out what this guy is, which is right here. So here, like you should have already seen, we can figure this out by using SOHCAHTOA. So we'll do that. We're going to put this in. We're going to say, I'm going to put it in down here. Okay. Is equal to, so looking at this, we've got the hypotenuse up here. We've got the angle, but we're looking for this guy. We're looking for our adjacent. So because it's adjacent, so SOHCAHTOA. Since it's adjacent, we'll be using cosine. So we're going to substitute this guy out because this is what this equals to. It's going to be the final momentum of our first object in the x direction is equal to, that one is the adjacent, so it's going to be the P1F, this guy right here, P1F times the cosine of theta, which just translates into 20 times the cosine of 30. Okay, and we'll insert that down here. So 20 cosine 30 plus P2Fx. We'll add, this will become now 30, or it is 30, I should say. It is 30. So then we just do this. It'll be 30 minus 20 times the cosine times 30 is equal to all this good stuff. Now, real quick, I know I'm bouncing back and forth from all this stuff. Real quick, this one we can just solve real quick. That is going to be 17.3 kilograms by meters per second. Okay, so it'll just be 30 minus 17.3 equals 2P2Fx, which then is going to leave us with this for our x momentum, or for the final momentum of our second object in the x direction of the x-axis, which is going to be 12.7 kilograms by meters per second this way. Okay. So we'll save that for a hot minute, because this is going to go in our second triangle, so we'll keep this for a second triangle. Okay. So, and now we've got this, and we use this in order to find this. Okay. Because remember, this, our initial momentum needs to equal our final momentum. In this case, we're looking at it on the x-axis. So the initial momentum on the x-axis was 30 kilograms by meters per second forward. Our final one here has to equal that. So we used that. We did that over here, and we found out what the momentum is in the x direction for our first object. And then we put it into the equation, this equation, to find it, 30 minus 17.3, which is then going to equal to our momentum in the x direction for our second object, which is 12.7. Okay. So now, before we move on to the second one, let's find this guy, because we need this too for basically the same same way. Sorry. So we'll say this is all of our x stuff. So now let's look at our y stuff. So it's pretty much exactly the same thing. Okay. The initial y is going to equal the final y. God, sorry about that. Our initial y is going to equal to the final y for momentum. Now, what is our, what did we find? Did we already do that? Did we do that? Let's see. I want to say I did. No, I didn't. So let's do that. Let's do the same thing we did up here. Separate that. We're going to do the same thing we did here for the y. So first, let's find this. So we know that the initial y momentum is going to be equal to all this good stuff. Now, what's great is the fact that this is super easy, because both objects, this guy's not even moving at all. This guy has no y direction at all. It is only moving horizontally, so both of them are 0. So our initial y momentum is just 0 kilograms meters per second. Okay, easy peasy. So that must mean then, and hopefully what this tells you is that this means that the y, the final y momentum of one ball is going to be the opposite of the other. Okay, how do I know that? Well, if PIY is equal to 0, it's going to be 0 is equal to PFY. Okay, which then is going to turn into 0 is equal to P1FY plus P2FY. And so what that'll look like is just, P1FY is equal to a negative P2FY. Okay, so they'll be equal but opposite in sign. Okay, so that means once we find this y momentum, that means that the y momentum for our second object will be the same, but it's in the completely opposite direction. So let's solve for that. So let's solve for this guy. I'm going to repeat kind of what I did over here. So P final y is equal to P1Fx plus P2Fx, okay, which is actually Pix, which we did over here. Oh, Pi, my goodness, y, not x, but y, sorry, which is just this over here. So I'll just set this to this. Okay, so I'm going to set it to this guy over here, and I'm going to do this. 1Fy is equal to 2Fy negative. So I'm going to substitute this guy because this one we can find using our triangle up here. So P1Fy, the final momentum in the y direction for our first object is just simply, using SOHCAHTOA, is simply going to be this. It's going to be P1F, this guy right here, times the sine of theta. Okay, so I can just substitute that in for this guy. So then it will be 20 times the sine of 30. It's going to be equal to the negative P2Fy, which is going to give me 10. I move that negative over, and my final momentum in the y direction for my second object is going to be a negative 10 kilograms. Oops, I'm now seeing that this isn't in the camera. Negative 10 kilograms by meters per second. Okay, more specifically, 10 kilograms by meters per second downwards. Okay. So now I've got this guy up here. This guy is 10 kilograms by meters per second. And I've got that. Okay, whew. I know, a whole lot of work. Hopefully this is not as confusing as you thought it'd be. So now, what we have is this. Let's now put this together in a picture. So let's draw a picture of our second object after the collision. So the second object after the collision, its triangle is going to look like this. So, and we've now found this guy out. So this is going to be the P2Fx. And this is the 12.7 kilograms by meters per second this way. And we also have this guy. We have the P2Fy is equal to 10 kilograms by meters per second down. Okay, so we can then we should be able to see that we can use inverse tangent to find out phi here. So the tangent of phi is going to be equal to just opposite over adjacent. So that's going to be phi is equal to the inverse tangent of opposite, which is 10 over 12.7. Yes, 12.7. And then phi, what we'll see here, phi, you should get 38 point. I just had it. Where did it go on my piece of paper here? It should be 38.2 degrees is what we should find. Okay, so phi here is 38.2 degrees. Okay. So I've got phi, I've got these two. Arguably, I could just find the final momentum using these two, you could use, arguably you could use just Pythagorean's theorem here, which I'll wait to use that. I'll use that to double check everything here. But let's just, so now that we've got our angle, let's just use, I don't know, let's just use sine. So because it's sine, because it's, SOHCAHTOA, so TOA, we'll use sine, opposite over hypotenuse, because this is going to, nope, not that one. This is going to give me this. Let's see, this is going to be P2F. So it's then going to be sine of phi is equal to opposite over hypotenuse. I'm trying to find hypotenuse, so then it'll be hypotenuse is equal to opposite over the sine of phi. Okay, which that's actually now going to turn into the final momentum of our second object is equal to P2Fy over the sine of phi. Plug all that in, it'll be 10 over the sine of 38.2. So popping that in the calculator, it'll give us 16.17 or 16.2 kilograms by meters per second. We're not done yet, because this is only momentum and we need to find the final velocity. So in order to do that, it's just P2F. Let's see, all we're going to do, I'm just going to put it right here, divide that by its mass, which is 5. 16.2 divided by 5. And for our final velocity for our second object, sorry for the bell, we'll get 3.24 meters per second, moving at 38.2 degrees below the horizon. And we have our answer. Okay. Now, this should check out, and pretty much the operations that we used, basically have double checked our work. We've used the conservation of momentum in order, to our benefit here, to show us that that momentum in the x direction is, initially is equal to the final momentum in the x direction. The initial y direction momentum is equal to the final momentum in the y direction. So there really isn't any, double checking other than maybe just making sure that we did something right, in here. So let's use Pythagorean's theorem to see if we get, first off, if we get this, the momentum, and then divide that by 5 to make sure we get this. So using Pythagorean's theorem, a squared plus b squared is equal to c squared. So the square root of 12.7 squared plus 10 squared, I get pretty much exactly what I calculated right here. What I get using Pythagorean's theorem, I get 16.2 kilograms by meters per second as well. So that checks out. That means that my math here was good and that I'm good to go. And my final answer here is going to be 3.24 meters per second, 38.2 degrees below the horizon. Okay. Oof. So that is Check Your Understanding number 2. Make sure you go ahead and watch the video for Check Your Understanding number 3 as well. I'll see you in the next one.